this video is for the three-sided truncated pyramid. I want to start off by saying be careful when you draw the original views. Your development won't turn out perfect on this one. You'll find out because of decimal rounding, and when I say perfect, I mean that edges that meet during folding won't be exactly the same length. They should be very, very close. I'm talking about, probably less than 1/1000th of an inch, but they won't be perfect. But the way you construct your front, top, and right side views matters very much. So make sure all the dimensions that I gave you were correct, but also try to draw it in such a way where this line is parallel to this line, and also this line is parallel to that line. Okay, so we'll go ahead and get started. The first thing I see, and the easiest thing, is probably this small triangular piece. So I've already created a construction layer, and I'm going to create that small triangular part of the development with an auxiliary view. So I will just do this through the revolution method. Let me take a measurement from the midpoint of this line to the end point, and that's 0.5237. So let me offset that and 0.5237 in each direction. And then I will go to my visible layer and draw a line and make my triangle. Okay, and then I will just move that over here somewhere. Okay, my ortho is turned on, so let me put it more over in here. Okay, so now let's work on this side panel here. We need to create an auxiliary view, but this is a little different than the way we would normally do it, because we're going to do it from the top view, but we need to project perpendicular to this face. And like I said, these two lines are parallel, so if I project perpendicular to one of these lines, then I'm also projecting perpendicular to the other line by default. So what I'll do is I'll go into my construction layer, and I will draw a line. I've typed in L, enter, and then I'll type in PER, enter. And I just want to pick out a point on that bottom line there. Okay, and then I will move that into position. I should point out something before we progress any further. This line, this line, this line, and this line are all true length in the top view. The rest of the lines are not. These lines, these three here, are sloping away. Well, actually, all of them are sloping away from the top view. Okay, so they're not true length. The ones that are highlighted there are true length. In the front view, this is the only true length line that's actually in the drawing. This is sloping away because this whole face is sloping away. This one's not, though, because it's straight up and down, as you can see in the right side view. Okay, so it's not sloping away, and so therefore we actually see the true length of that line in the front view. Now, this line is not showing true length in the right side view, so don't get confused there, because as you can see, it's sloping away. The only true length line in this view is this horizontal line that you see there. Okay, so just want to point that out real quick. Okay, so I'm going to copy this construction line to my points of interest. Okay, so I'm going to go on what I know about this line, and I know it's not showing its true length, but I know I can find it. So let me use that technique that we've learned to find the true length of this line. Okay, so I'm going to draw a oh, actually, let me do it from the top. I'll draw a line or circle from here with the radius of the length of the line here. Then I will draw a line from the quadrant straight down. Make sure you have either ortho or polar turned on. I'll draw a line from left to right there, and then draw a line from here to here. Now the true length of that line is 4.9833. Okay, so let's use that property. I'm going to draw a circle up here, 4.9833, and then I will go into my visible layer, and I will draw a line from here to this intersection. Okay, so what have I done? I know this line has to be 4.9833. I just found it, the true length of that line, through using the revolution method. Okay, and I projected perpendicularly from this point. Okay, so I'm creating a layout in a little bit of a different way than we normally would. Now this line I mentioned is in its true length in this view, the front view, and if I go to my properties panel, I see that that is 3.7991. So let me go back into my construction layer and draw a circle with a radius of 3.7991. I'll go back into my visible layer, and then I will draw endpoint to intersection and then over to the original line. Okay, so this is 3.7991, and this is what it is. Now it's showing 2.4998. This edge should align with the edge on the small triangular piece that we created earlier, but as I mentioned, due to rounding, this is probably not going to be the case. The edge here is 2.4998. The edge here is 2.5050, which is 52 ten-thousandths difference. So it's very close in an acceptable amount. If your difference is like a tenth of an inch, then that's too much. Something's happened. Okay, so now as far as planes go, the area bounded by this triangle, I can see the true size and shape of that plane. So what I'm going to do now is I'm going to copy that triangle and this part of the development. I'm just going to copy it out. Okay. Then I'm going to use the mirror command. I'm going to highlight those three lines, and then from the midpoint, make sure you have a midpoint snap turned on. I'm going to let that be the first part of my mirror line, and the end point of the line to be my second point of the mirror line. And do I want to erase source objects? The answer is no. Enter. So now let's work on the left side of the object. I think before I do that, I'm going to create a new construction layer. I'll just call it construction 2. And I will make that the same or similar color. And what I'm going to do is I'm going to put all these construction lines that I've already used on my construction 2 layer just by highlighting them and then selecting construction 2, and then I will turn construction 2 off. So I still have them in the drawing, but they're not in the way. Let me erase that since I already have it copied over here. Alright, so let's work on the left side of the object. Again, I know the true length of this line is 4.9833. Okay, so that might come in handy to know. I also know that the edge view of this plane has a length of 4.8867. So let's utilize that number. Let me offset 4.8867. Okay, and so that gives me a distance from here to here, which is something I definitely want, because if you think about the layout and a circle there, the radius would carry us over here. Okay. Let me just show you a little trick here on this one. I'm going to copy from the midpoint of this line, and I'm going to just drop it right on top of this one, and then I'll, did it copy? Yeah. See, I have that short line laying on top of this other line now. Let me erase the longer line, and then, I actually did not need to create that construction 2 layer. It doesn't appear. And then I will connect these lines, and that should be our layout. Let's see if this line is 4.9833, and it is. You can see that we kind of created it in a backwards kind of way, but this is a good exercise. So let me copy. There's no construction to actually show there. I'll copy that from there to there, and let me first rotate this by 180 degrees. Rotate. And then let me just move this into I hit the help. Move this into position, and then I can just go in and I will make those phantom lines, and I changed these to folding or phantom lines to indicate that this is where the object would be folded. Um, and this is the completed development. Now, as I mentioned earlier, it's not perfect. If during folding, this line will meet this line, and those are both lines are 4.9833, which is perfect. Same thing on this side, of course it should, because these are mirrored. This line will meet this line during folding, and those are both 3.7991, which is exactly what we want again. The only error, if you want to call it, and it, like I said, is due to rounding probably. These lines I came up with are both 2.4998, and during folding it will meet this small triangle, and these lines are actually 2.5050. Um, and it's not exactly perfect, but it is close. Now, as I mentioned earlier, it is pretty easy to possibly make a mistake on your front, top, and right side view. So I haven't decided what the reasonable range of error is going to be on that, but if you come up with slightly different measurements than I did on this video, they may be acceptable. But you want to, again, try to make sure that all of your measurements that I gave you in the handout are correct, and then make sure that this line and this line are parallel, and this line and this line are parallel. Of course, make sure it's symmetric. In other words, this line should be the same length as this line. That will make and make sure you project from view to view. Just make sure that your front, top, and right side view are as exact as they can be before starting with your development. That'll cut down significantly on the errors. And that concludes this video.